Okay, so we're going to solve the equation z times the absolute value of itself equals 15 plus 20i. Now, some of you might already see this, right? The numbers here were picked for a reason. They are nice numbers. Here we could factor out 5, which leaves us with 3 plus 4i. Now, if you're already familiar with the absolute value of complex numbers, by the way, z is a complex number. Right, you might already notice here that z would equal 3 plus 4i, and therefore the absolute value of z would be the 5, right? This is because complex numbers, which can be broken down into their real and imaginary parts, the absolute value of that is the Pythagorean theorem, right? It would be the square root of x squared plus y squared, right? So all that's going on here is that 3, 4, and 5 form a Pythagorean triple. But let's say you didn't spot that or you weren't aware of that. How would you go solving this by hand? So what we'll do is we'll break apart z into its real and complex numbers. So, real and imaginary parts, as we already did up here. So let z equal x plus yi. Substituting that into the equation gives us x plus yi times the absolute value of x plus yi. And then we'll distribute. Or not yet, we're not distributing yet. Let's go ahead and change that into what it equals. So the absolute value of x plus yi is the square root of x squared plus y squared. And then we will distribute that to the other two terms. So here we have x times the square root of x squared plus y squared, and then yi times the square root of x squared plus y squared. Now we want to set the real parts equal to each other and the imaginary parts equal to each other. So the real part over here on the left side, real parts, that is. Okay, so on the left side here, that would be x times the square root of x squared plus y squared, and that's going to equal 15. The real part on the right side is 15. I'll do the same thing with the imaginary parts. So on the left side, that would be y times the square root of x squared plus y squared, and that's going to correspond to 20 on the right side of the equation. Good. So now we have a system of equations we can use to solve for x and y. So to get rid of the square root, let's go and square everything here. This would be x squared times x squared plus y squared equals 225. Then distribute the x squared, so x to the fourth plus x squared y squared. And then we're going to go ahead and solve for y squared, which is what we will substitute out here momentarily. So that would be y squared equals 225 minus x to the fourth divided by x squared. All right, do the same thing over here with the imaginary parts. So we'll go ahead and square both sides. And then we can go ahead and distribute now. So that'd be x squared, y squared, plus, and then I'm going to leave this as y squared squared, right? As you see, we are going to substitute in that y squared. So when we substitute the y squared into here, notice this x squared and the x squared in the denominator over here will cancel out, which means for this part, we just have 225 minus x to the fourth, and then plus. And then right here we'll have the whole thing squared. All right, good. So now we have substituted out the y, and we only have x in this equation, so we can go ahead and solve this. We don't really need the first parentheses here. And then I'm not going to square the numerator just yet, but the bottom, that would give us x squared squared, or x to the fourth. So to get rid of the fraction in this equation, we can multiply the entire equation by x to the fourth. This gives us 225 x to the fourth minus x to the eighth. And then I'll go ahead and distribute now. That's going to be 50,625 minus 450 x to the fourth plus x to the eighth equals 400x to the fourth. Remember, we did multiply the entire equation by x to the fourth. Combining like terms here, well, the x to the 8s cancel out. That's nice. And then we have these two right here, 225x to the 4th minus 450x to the 4th would give us negative 225x to the 4th plus our 50,625. And that's going to equal 400x to the 4th. So I'll go ahead and add my 225x to the 4th to both sides, giving me a 625x to the 4th equals 50,625. Divide both sides by your 625, take the 4th root, and you get that x equals 3, right? So we're seeing it here. We're seeing it come together. We did get our 3 there for the x. Now, if you remember here, y squared equals 225 minus x to the 4th, which would be 3 to the 4th, over x squared, or 3 squared here. So that's 225 minus 81 over 9. 225 minus 81 divided by 9 is 16. So we got y squared equals 16, or y equals 4. Good. All right, so there you go. The real part of z is 3. The imaginary part of z is 4i. So z equals 3 plus 4i, and the absolute value of that would be 5. Same as what we thought from the beginning.